Almost done. All right, so we're gonna let S be the region in the second quadrant bounded by the graph of that and that. And so I'm seeing a picture right here. So nice of them to give us a picture. As this guy right here is not familiar to me. I don't know what he looks like. I'm going to have to do some work to see what he looks like. I do know what this guy looks like. This guy is clearly a line. He's a linear expression. Okay, so we know that this one is, that one's that, and this guy right here is our linear expression. As shown in the figure above, the graphs intersect at A and 0. Well, I don't know where A is, but I do know where 0 is, and I do see there are points of intersection, so that must mean 0 goes right here, and A must go right there. Okay, which of the following gives the volume of the solid? Okay, so we got all these expressions generated when S is revolved about the line y equals -1. Now, where is y equals -1? It's off this graph. It is down here. So that's our volume of revolution. I extended our y-axis right here so we can see it. Now let's color in our area, and let me show you guys what this solid kind of might look like. Actually, not the whole solid, just a cross section. So if I go from the most outer line, that's going to be our purple line because he's the farthest away from our axis of revolution. Our circle would look kind of like that. That's what our cross section would kind of look like. So we need to find the volume that has those cross sections. And of course, as I go down this right here and I pick different x values, I'll have bigger looking circles right here. But we don't need to draw all those. And then the inner one, the inner function, which is our green one, would be like that. Now, the green one forms like a void, like it's empty inside. So yes, we are going to be using the washer method. But the washer method is just a disk method twice, and then you subtract them. So we know that when you have a volume of revolution, all you're going to do is you have a scalar with a pi out on the outside, and you have your r squared on the inside, because pi r squared is the area of a circle. Okay, we just need the radius to be written in terms of x. So here we go. This radius right here for our purple one, you always need to, I mean, you could do it either way, but this is the traditional way. You do the curve, the most outer curve, then you subtract the axis of revolution. You always subtract the axis of revolution. And then I put my dx, and then my lower and upper bound. Yes, those were given to me. I have my a and my 0, so I put my a first, then my 0. And then for the other one, for the green one, that's the inner function. The radius is going to be the function, the really weird one, minus the axis of revolution. So here's the really weird one, and we're subtracting the axis of revolution. Now, to consolidate this, because we can, because they both have a pi as a scalar, they both have the same integral, lower and upper bounds, we can combine these. And what we're pretty much doing is we're taking the two radiuses that are already squared, and we're subtracting them. So it would look like this. There's our first one, our purple one. And then sometimes you can switch this because after we subtract these, normally mathematicians like to put the negative in the middle so they don't have to do two signs. But anyways, that's just a side note. I guess you didn't need to know that. And then our other radius, I put that guy in there. And this time, instead of subtracting the negative, I did add a positive. So that's what we got. That's our answer. Let's check out our answers over here. Now, you got to be really careful because some of these are made to try to fool you. It looks to me like when I look at this first one, this one gets eliminated right away because they didn't square both of the radiuses. They tried to put them together and then square the whole thing. That doesn't work. So that one's wrong. This one right here, they did the same thing, except they even went crazier. They were like, okay, now we're not even going to put the scalar, the pi, out in front. So I feel sorry for the dude that selected that one. Our next one, we're really close here because, look, we got both radiuses being squared, but we see a problem on the inside. It says -1, but it should say +1 because, right, we're minusing a negative. So this one's out. And our final answer is this guy.